So should I say a few words? Yeah, okay. So welcome everybody. We're truly honored to have a presentation from Professor Miroiu. Well, instead of listing a long sheet of facts, reciting a long sheet of facts about Professor Miroiu, I'm just going to tell you my personal take on Professor Miroiu's contributions, which are, let's say, different and more important than they are currently known or currently recognized. So he has contribution in philosophy, in analytic philosophy. He has contributions in political science and logic. And virtually, I don't know any logician in Romania who hasn't been influenced by his books or by his logical writings. And I would end my short presentation by telling you sincerely that, well, his contributions deserve more recognition than they currently have. So, Professor Miroiu, you have the floor.
Thank you. Thank you. I shall try to have my presentation by starting with the plan of my talk. You see, there will be three chapters. Unfortunately, I don't think that I'll have time to discuss at length the third one. Therefore, I shall focus on the first three. So I shall start by introducing some concepts in social choice theory in order to make things easier to understand. What is social choice? Social choice is the study of collective choices, collective preferences, judgments, beliefs, attitudes, and so on. It aggregates, it's a study of the way in which individual choices, preferences, beliefs, and so on of the members of a group, or we shall say sometimes, or society, are aggregated. How individual choices are aggregated so that to obtain a collective group social choice, preference, or belief, and so on. It means that social choice deals with many such things. For example, citizens in a country have their personal attitudes toward the candidates for a position of the president of the country. How will the president be elected? Usually, a voting rule is used. It aggregates the individual choices into a collective one. Situations in which we meet such rules are present in most situations in which we encounter other people, and even when we have to decide what to do based on different criteria. For example, when I decide in the morning what to eat at my breakfast. Methodological note, I think, is necessary to mention here, because I assume here in this discussion in general in social choice, it is assumed a methodological individualism, meaning that social facts, like for example collective decisions, are the results of aggregating individual facts, choices, preferences, and so on, and they can be analyzed in this sense. Phase two is an alternative. Then individuals can have three kinds of attitude: to accept that alternative option, or choose it, or reject it, or be unconcerned. The same when they face two options: choose, prefer the first, or choose, prefer the second, or be unconcerned, indifferent between the two. Or another way, choose or prefer both. Voting rules take individual attitudes as given and maps them into a collective one. How? By using, I said, voting rules, but there are quite many voting rules. And I should give some examples. The simple majority rule says something like this: given two options or alternative, the group chooses the alternative chosen by more individuals than the other. Absolute majority rule. It's close to the simple majority rule, but it's different. It says that given two options, alternative, the group chooses the alternative chosen by more than half of the individuals in the unanimity. Given two options or alternative, the group chooses an alternative if it is chosen by all the individuals in the group. Otherwise, the group is unconcerned. The consensus rule, which is close to unanimity but is different, and I will come back to this rule because I consider it to be very, very interesting, very important. Given two options, the group chooses an alternative if no individual in the group rejects it, but at least one individual chooses it. So no one opposes the alternative, and at least one supports it or chooses it. The plurality rule, which you know, given a set of options, the group chooses the option chosen by the largest number of the individuals in the group. And the final is the approval voting, somehow different from this. It says something like this. Given a set of options, each individual can choose or approve any number of options she wants. And the alternative chosen is the one that gets most approvals.
Unfortunately, so sorry for intervening, but unfortunately, we can still see only the title of your presentation. Oh. Not the slides corresponding to your point on the talk, in the talk. So if you could just move your to.
I don't know what to do. Now you see?
Yeah.
Okay. So there will be no. I should remain in this way. Okay.
Thank you.
Yeah. You see that one? Yes. Okay. Yeah. See? You see?
Yep.
Yes.
Okay. Yes. Okay. Well, the problem is then, why should we use one rule but not another one? What makes one rule to be preferred to another rule? And I wanted to give an example with this, which shows that using different rules, I don't want to say many things. If we use different rules, different alternatives are selected. For example, if we use a simple majority rule, W, the alternative W, will be selected. Why will be selected? Because if we look here, we see that when compared with each other alternative, it gets more votes than the other. And plurality, the rule, X will be the chosen alternative, because as you see here, it gets most votes. It is placed by most people on the first place, 18. Yes. By approval, well, we can. It is more difficult to count, but U and W get equal, and well, the first place, and using other rules. Well, the question is, Is there correct choice? What does correct means? The answer is this. When choosing about voting rules, we look at the properties the rules have and choose the one rule with the properties we prefer. The question is then, what properties these rules have? And the answers given by social choice theorists is that we can provide axiomatizations or characterizations of the rules. The most famous was given in 1952 by Kenneth May for the simple majority rule. He proved that this is the only rule satisfying the following four conditions or properties. These conditions are this: universal domain. Individuals in the group can choose in any way they want. Anonymity. All individuals in the group are equal. Their votes are equal. Third, neutrality. All options are equal. No option has a special status. And then fourth one, which is somehow more peculiar, is so-called responsiveness. If the group is unconcerned, then any individual can change the group choice in the sense that individual prefers. Well, here's a first interesting thing concerning the political philosophy, because these properties are ones that we usually like to connect to what democracy is and how democracy works. For example, universal domain is connected with the idea, the liberal idea that the individuals are free, they can choose in the way they want. Anonymity gives the idea that all individuals are equal in the book. Yeah. No one has a special status. Neutrality. There is no special alternative, for example, because it is given, it is proposed by some members of the group or something like this. But this is not what interests here. The idea is only that these four properties characterize only the majority rule, which means that if we accept these properties, then we have to accept the majority rule. And conversely, if we use the majority rule, it means that we have already accepted these four properties. Well, all is nice until we find the problems. The problem is that all voting rules face unhappy problems. What kind of problems? Very, very different. The simple majority rule, for example, allows for circular preferences. That is, the collective preference relation is not transitive. You can see in this simple example that alternative Y is strictly preferred to X because two members, A and C, prefer Y to X. And X is strictly preferred to Z because two members do this, A and B. But in the same time, it is not the case that Y is preferred to Z, but Z is preferred to Y. So we have the cycle because what we see, B and C prefer in this way. So there is a problem with this. The problem is even more difficult. As Kenneth Arrow showed, this is a famous result in social choice. No rule satisfies simultaneously some very desirable, nice properties, which are the following ones. The universal domain, strong Pareto, is something close to what I said about the consensus rule, meaning that if in the group no individual rejects an alternative and at least one votes for it, approves for it, then that would be the alternative chosen by the group. Third, independence of irrelevant alternatives and non-dictatorship. The final one, meaning that the group choice is not always the individual choice of some member of the group. Independence is somehow more specific property, but desirable one, which means that something like this, the group choice is correlated with individual choices. Even if individuals change their attitudes with respect to other alternatives, if their attitudes regarding the two options X and Y remain unchanged, so will the group be the same. These are only introductory things I wanted to present. So I shall come to the main part of my presentation. And I want to argue that these aspects of social choice can be represented in different ways in logic, in many ways in logic. I shall deal only with two logics, modal logic and many varied logics. I should start with modal logic. Well, the main intuition is this. Preferences can be described by sentences. For example, when I say option X is preferred to option Y, each individual has an attitude towards such sentence, acceptance or rejection. So for the moment, accept that unconcernedness is not allowed. Then a collective preference has the form. By the rule ρ, option X is collectively preferred to option Y. Take ρ, for example, be the majority, simple majority rule. Logically, we use here a logical operator applied to a sentence. It aggregates individual preferences into a collective one, like this. In modal logic, we have something like this. In more words, we have the truth value of a sentence P in word 1, in word 2, in word 3, and so on. While, and given this, we construct the modal status of P. For example, if we work in the most simple modal logic in S5, then we say that P is necessary if it is true in each of these words. Yeah. Something similar happens when we want to aggregate individual preferences. We have the individual preferences of this individual 1 concerning P, the individual 2's attitude concerning P, and so on. And we get the attitude of the group concerning P. Yeah. So the idea, the general idea which I consider to be very, very important is this. And this is one intuition that will be further developed then, is that in logic, modal operators are aggregators. They aggregate. For example, a modal operator aggregates the truth values of a sentence in different words. or a connective conjunction, dejection. What does it make? It aggregates the truth values of some proposition sentences to get a truth value of the compound sentence. The same thing happens here. If we have, for example, the unanimity rule here, we get something similar to the S5 modality. What would that mean? That we have a collective choice, unanimous collective choice. Just like in the case of the modal status of P, or necessary P, the group collectively accepts P if each individual accepts P. But this should not be the same every time, because if we have the simple majority rule, then the idea is that at least a majority of individuals accept P. So we get a different logic. For example, try to write necessary P, this very usual symbol, and read, by the simple majority rule, the group prefers X to Y. In this way, we can try to construct a model logic of the majority voting. And as you can see, that some very well-known model formulas hold. Think here of the way in which you read this expression. In S5, this reads, P is true in all the words. At the majority logic, this reads, P is true in a majority of words. But we have this. It is not the case that both P and non-P are necessary. When you choose, you cannot choose both P and not P by the majority rule. No, this is not necessary. The K expression, if it is necessary that P implies Q, then if it is necessary then P, we have also necessary then Q. And well, this I have put this in red because they are in a way more interesting, but in the same time more not very easy, but not very easily accepted. What does it mean? If this P is chosen by the collective, then the collective must accept that it accepted P. This is the idea. And if the collective, the group rejected P as a collective, then the collective must accept that it rejected P as a collective. Which are some very interesting. But some properties fail. For example, this well-known expression, which holds in many modal logics. If P is necessary and Q is necessary, then P and Q is necessary. It doesn't hold in majority logic. Well, it's simply why. For example, we have 3 members of the group. What does it mean that P is necessary? It is accepted by 2 members, A and B. What does it mean that Q is necessary? It is accepted by 2 members, for example, B and C. But P and Q are both accepted only by A, by one of the members of the group. So it is not necessary because it is not accepted by a majority of the members of the group. Well, different authors are succeeding in formalizing this main theory of social choice, including the axiomatization of different voting rules and errors theory. Well, I shall not speak more about this because just in this moment I'm working with my colleague, with Mircea Dumitru. We are working just on a paper on these issues, and we are still in our work is still in progress. So I shall move to the second type of formalization of the logic of the majority logic in Lukasiewicz three-valued logic. This is the results I shall present. Have been published recently in a series of articles. One is called Collective Choice in Aristotle. Cătălin Parteni, he knows very well Greek, and because we discussed Aristotle, we had to be careful with the Greek text of Aristotle, and therefore we had to cooperate. The second was published 2 years ago, Majority Voting in Higher Order Societies, and the third one last year with Mircea Dumitru. It's called Representing Voting Rules in Lukasiewicz's Three-Valued Logic, and I shall focus on this paper and the results there. Okay. The analogy. The intuitive idea is that logical operators, I repeat, are similar to voting rules. A voting rule gives a social preference for each distribution of preferences of the members of the group. Similarly, logical operators give an aggregate truth value for each distribution of truth values of the propositions they connect. Well, let PI mean the individual AI prefers in X to Y. If P, Greek P, is a binary logical operator, then pi of applied to these two sentences gives the aggregate attitude of the group form of the individuals A1 and A2 with respect to the two alternatives. And similarly, for n-ary operators, except that in the case of n-ary operators, we have the attitude of the group form of n individuals. For example, the expression Pi or P2 expresses the attitude of the group form of two individuals, A1 and A2, which follows the most favorable attitude to X of the members. And similarly, in the case of n-ary operators. We work in L3. The truth values will be denoted not as we use in to do it in logic, 1, half, and 0, but 1, 0, and -1, where 1 means that X is preferred to the other alternative, -1 means that the other alternative is preferred to X, and 0 means that they are equal, that the group or the individual is indifferent towards the two alternatives. And the question that immediately comes to one's mind is if logical operators corresponding to well-known voting rules, like the simple majority rule or other rule, can be identified in a given logical framework. Is there a logical operator in L3 that corresponds to the majority operator? Well, these are two examples of logical operators in L3 for the implication and for the disjunction. You see that there are the well-known definitions here. For example, in the case of disjunction, you see that this disjunction aggregates the two options, the two attitudes of the individuals, and selects the most favorable attitude towards the first alternative, X, which is the usual implication. Here is the logical operator in L3, which corresponds to the majority voting. And it means something like this. There are two individuals with two different attitudes. If both prefer X, then of course that is by majority logic rule preferred. If one prefers X and the other is unconcerned, then X is again accepted. But if they have opposite attitudes, then the group becomes unconcerned, which is given by this. The other cases are similar to this. Of course, the case of -1, some things are analogous to the case when we have preference for the first alternative. Well, in the case of binary operators, the binary operator for the simple majority rule and for the consensus rule are identical, but they are not identical when we move to n-ary operators, because they have different properties. But the idea is that in the case of the binary operators, we succeed in finding such an operator corresponding to the simple majority rule, for example. Well, but what is the status of this simple majority rule? First, it can be defined in terms of three operators in L3: implication, negation, and T. You know that T is a logical operator in L3, which, given a sentence P, always has the value zero, or usually half. For example, we can define the majority operator in this way. This result is not new, is not surprising. In fact, it's a corollary of theory of Slutsky. He proved that the set of the three operators is complete, which means that all the operators in three-valued logic can be defined in terms of these three operators. It is interesting, and you know this, that the set consisting only in implication and negation is not complete in L3, while in L2, in classical logic, it is complete. We can define all the operators in terms of implication and negation, or in terms of disjunction of negation, and so on. In the case of the three-valued logic, which is three-valued logic, we need T to get a complete set of a set of operators which is complete. Well, but it is possible to show that all the binary logical operators can be defined in terms of one binary operator, me corresponding to the majority, and two unary operators, negation and false. Well, this is a different result. You see, T can be easily defined. Can be easily defined because we have P, we have a non-P negation, and when we aggregate P and non-P, we have we get unconcerned. The group is unconcerned about this. And then we can also define implication. Well, this is a more complex expression. Why it is interesting, and I put a superscript here, to meaning that this is a binary operator, you see. But it can, in fact, we can in fact use the ternary operator of majority, meaning we get that if we have three individuals, a group of three individuals, we can easily define this in this way. It's not intuitive, but the idea that we can do this. This is interesting, and we'll see why immediately. The rule, the majority rule applied to a group of n individuals is something which is very interesting. It applies to many individuals, and the problem is what properties this n-ary operator has. The result that we obtained and we presented is that the n-ary operator can be defined in terms of a binary one, which means that all applications of the majority rule to a sequence consisting of n members can be defined in terms of applying the binary majority rule to sequences containing only two members. Yeah, an example was here. Well, suppose we have a group of three, and this can be defined in a sequence of applying the binary majority rule to different sentences and applying it iteratively. This is very important. This is the first interesting result which I want to note. Well, the comment on this result is this. Usually, no special interest is given in social choice theory to the number of individuals in the society's voting to which voting rules apply. One only mentions that these societies consist in an arbitrarily chosen number of individuals. However, it is possible to show that reducibility may work when we start with the binary component of a voting rule, that is, with its applications to society's form of only two members. And we proved that many voting rules have this property. They can be extended in the sense that applying them to a society form of an arbitrarily large number of members can be reduced to iterated applications of their restriction to society's form of only 2 members. This holds for the majority rule, but we proved that this doesn't hold when we move to other rules, like, for example, the consensus rule or the absolute majority rule. They cannot be extended. The NRA operator corresponding to, for example, the absolute majority rule cannot be defined in terms of the binary operator of majority rule. Now, another result, and I think this is the most interesting one, is this, that the consensus operator, NRI, consensus operator, cannot be defined in terms of the simple majority NRI operator. But conversely, the simple majority, the simple NRI majority operator can be defined in terms of the NRI consensus operator. This means that the majority and consensus cannot be sharply separated. That, in fact, logically speaking, majority is just a more intricate form of consensus. So the formal result is simply something like this. Given a group of people, so n sentences, then applying the majority to this group to get the collective, the majority collective choice of the group, corresponds to a very complex, a more complex sentence in which only the NRE consensus operator occurs, and which gives in all cases the same truth value as the first sentence. Well, what is the significance of this result? Well, it may be an interesting philosophical result, because the received view on the relations between unanimity and consensus and simple majority is that they have logical different structures and have different contexts of applications. For example, while unanimity and consensus are properly used in constitutional matters, the majority rule, both simple and absolute, is to be applied at the post-constitutional level. This view is a very old one. One can find it mentioned in the works of Locke, of Rousseau, thinking about the classics, and it was developed very much by the contemporaries. For example, in the famous work of Buchanan and Tullock, The Calculus of Consensus. Thinking of Rousseau, he mentioned it in The Social Contract, Book 4, Chapter 2, where he says that except in the original contract, the vote of the majority always binds all the rest, which means that in the social contract, we have to appeal to the unanimity or the consensus rule, while after the contract is established in all post-constitutional matters, we have to appeal to the majority rule. And he Rousseau developed this idea in a book he devoted to the analysis of the Constitution of Poland. And he discussed the fact that it gets into huge troubles. And the troubles come especially from the fact that in many cases, the Constitution required unanimity. Unanimity which blocked, in fact, the decisions. And he said, well, because there are issues that are not so very important to be placed at the constitutional level, they should be decided on a different type of rule, or majority rule, or even supermajority rules, but not the unanimity or consensus. One can think about this difference also when we take into account, when we think about some contemporary thinkers. For example, the most famous political philosopher, I think the most famous political philosopher of the 20th century, John Rawls. He devised his social contract theory, and he noted the differences, the different cases in which majority and unanimity have to be used. So the idea is that consensus and majority are, however, very different rules, and they have, because they have very different rules, we can think about different domains in which, or contexts in which can be applied. Now, this result shows, however, that the two rules are not so very different, because majority is in fact a very complex way of expressing the consensus rule, which is, I think, an interesting result. Of course, the question comes for the philosophers: is it legitimate to infer philosophical thesis on the basis of such technical results? Well, I think it is this is something to be discussed, and I only wanted to to note the fact that we can do this, but I didn't do this very clear. Now, third one, semantical reconstructions. Unfortunately, I was sure that I have no time to discuss this, and soon a paper of mine called Theories of Social Welfare Functions, a Semantical Approach, will be published in Theoria, the Swedish Journal of Philosophy and Psychology, in which I present a semantical reconstruction of the social choice theories, for example, of the theory of the majority rule. The idea is to reconstruct it in a semantical way, appealing to the ideas of Van Frassen, and especially of the structuralists. I mean, Sneed, Stegmüller, Molines, Balzer. These are the ones in which are used to reconstruct such theories. Well, thank you. This is what I want to present.
Thank you for the terrific talk, Professor Miroiu. And Now, the floor is open for questions, remarks, suggestions. Please raise your hand or just write in the chat if you want to intervene. I see that Andrea Popescu is the first one to, well, comment on Professor Miroiu's presentation. So go ahead, Andrea.
Thank you very much, Professor Miroiu, for the presentation, for the challenging presentation, both philosophically and logically. I was wondering, because of course, the main point of interest for me, at least, is the last point you've made, that, okay, so we have these results in logic, and this means that there is actually no difference between, or it's not a difference, it's just a gradual difference between majority and consensus. And I was wondering first whether we should resist the philosophical position that they're different and just try to make things in logic different, or should we accept the results from logic as a philosophical standpoint? And this is my first, it was more like a comment, but the question is the following, because when you try to model types of voting through model logic, use the necessity operator, and well, a sentence is necessary if a majority of worlds pick up that sentence. And I was wondering from that point, why don't you make a difference between consensus and majority within model logic? Because it seems to me that even when you applied, when you modeled it through model logic, you made this assumption that they're not different. Thank you.
May I answer? Okay, I'll start with this, the second question of Andrea. I didn't discuss the consensus in the case of the model logic. So I didn't say that they are similar. I only wanted to discuss in the case of model logic the majority logic, not the consensus logic. This is different. There are attempts to formalize the logic of the consensus voting in model logic. There are some attempts to do this, and they work very well. What I wanted to was to say, just to take majority logic as an example of how can we model social choice concepts in a model logic. If you use different other logics, voting rules, we get different logics. And also for the majority logic, the problems are very, very difficult, because one can offer easier semantics of the logic using, for example, if you know so-called neighborhood semantics, but it is much more difficult to formalize the model logic of majority in a simple model language. Well, it seems that we have to appeal to a more complex language to make sense of the properties of the majority operator. But I don't want to discuss more about this. But the idea is that one can use only, one can appeal only to model logic of majority, or one can discuss in general. And when we discuss in general, for example, we define a model operator which may be interpreted in different ways according to the properties we let it satisfy. And in this general frame, one would like, for example, to model classical theorems of social choice theory, like, for example, the Arrow's impossibility theory. So it's a more general aspect like this. Secondly, and now I come back to your first question. Well, the connection between social choice and philosophical aspects is very, very close. From the very beginning, since Arrow in the 50s, people wondered that social choice theory is nothing but moral theory disguised in formulas. And therefore, that they considered that the implications are very, very important. From logical results, formal results in general, not only logical, but formal ones, like the ones that have been presented by Arrow and other economists in general, economists and political scientists and even philosophers provided such theorems. And many of them have been philosophically interpreted in different ways, in moral and political philosophy in general, moral philosophy. It Rawls appealed to such formal results and discussed them and accepted their philosophical significance. For example, when he discusses the nature of the post-contractual stages. And therefore, I think that although these results are formal, yes, they can support in one way or another some more general thesis or implications. I think they can do this. Although, of course, like everywhere, it depends upon the fact that when you formalize an argument, you make very many simplifying assumptions, and therefore they can distort the argument and the relevance of the argument.
Yeah, Marianne, go ahead.
Thank you very much. Thank you for your presentation. Do you hear me?
Yeah.
Okay.
Yes.
So let me. My question concerns the basis of your discussions with Andrea. So you said that the result is that, if I got it correctly, that majority rule can be reduced to consensus rule, right?
Yeah.
And then you discuss some philosophical thesis, but I wonder, how can it be reduced to, how can it be defined in terms of consensus? So let's take a simple case. Suppose I have the majority rule for 3, for let's say A, B, and C. I suppose the only way I see it right now is to define it by the majority for ABC. It's either unanimity for ABC, or unanimity for A or B, or unanimity for or A or C, or unanimity, of course, for B or C. And if that's correct, then it's not a reduction between majority rule and consensus rule, then or unanimity, then it is a reduction between majority and unanimity plus disjunction, which like totally changes the matter. Did I get it correctly, or is there a way to define, as you say, majority rules in terms of only the consensus rule?
Well, it is not just this. The expression which reduces the majority to consensus is somehow more complex than the one that you mentioned.
And what other operators are there involved, if I may?
No. There is no other operator. It's an iterate use of the consensus. So it applies.
Yeah, it's a consensus between 1, 2, or
and consensus between consensus.
Yeah.
In this way. But if is this done, it is only you get a sentence in which only consensus occurs. Only consensus, not conjunction or disjunction. But even if
plays its part, yes.
Even if it would involve conjunction or disjunction, then this conjunction and disjunction can be reduced to consensus. But it does not include. I shall send you the paper so that you can see. I shall send to Paula. Yes, and please send then the papers to all interested people.
Okay, yeah. And another question, if I may. So yes, then it may be possible because the iteration plays the part of.
Yes.
Yeah.
So
that's an interesting issue to see how far it can go. Okay. The second question which I have is, you said that you don't discuss semantical considerations. At the same time, in L3, if I saw correctly, and maybe also in the modal part, the aggregators, or for example, the majority rules, were defined semantically. So basically, you define them by truth tables, at least in this presentation.
Yeah.
So do you have something on the proof theory part, or are there introduction or elimination rules which are practical? I don't see how, but I'm just asking. Or is it just a semantical construction?
No, it was not only the semantical one. I showed in earlier slide, or some slide, that it can be defined syntactically. Syntactically, not only semantical.
Okay, maybe I haven't seen it, sorry.
Yes, it can be defined syntactically, and in this way I used Superski's theory. Yeah, yes. But I must confess that I prefer semantical, as I don't like so much to work in proof theory. So.
Yeah. Okay. And Adrian, may I have a third question? I try to be brief.
Sure, go ahead.
Okay. So my question is quite general because I haven't seen these kind of reconstructions of social choice. But when I touched a little on a related subject, my problem was how do you treat, for example, non-majority because you have a 50-50 situation. So basically you have an even number of voters, which is quite obvious. Also, your theorems are, for example, your theorem in modal logic is affected by that, I think. So if you have a 50-50 split, then you don't have a majority, you have the negation of a majority, but then in order to, you said that the negation of a majority is a rejection, if I got it correctly.
No.
So if you don't have, you read the modal operator.
No, it's different to have a rejection, necessary non-P, from non-accepting the majority, non-necessary P.
Okay, so
yes. So it works. It is possible for the group to be unconcerned. It doesn't accept P and it doesn't accept non-P.
And my question was a little general. Well, does this problem affect a lot your logical elaboration?
No.
Okay.
Not at all.
Thank you.
Other questions or comments? Well, I have a kind of a, let's say, suggestion or maybe an exploratory question here.
Yeah.
I thought about the possibility of, well, kind of endowing the model logic with probability theory, in the sense that, well, my initial thought was to weight the accessibility relation by probabilities and see what you got from such a machine, from such a, let's say, hybrid machine. For example, well, we all know that throwing 2 dice amounts to 36 possibilities. And you have an accessibility relation, for example, that I would weight with 1/36 to get a 6/6. But I have 7/36 to get a sum of 7, right? A 6/36 to get a sum of 7, because there are 6 possibilities. And I was wondering if one can do that, and if one can obtain or model social choice preferences using such a machinery, in the sense that in such a hybrid, let's say, framework, it could happen that often, or that tautologies that are accepted in some system of logic, of model logic, fail to be tautologies, or fail to be valid in such a framework. And maybe this could be a more adequate system for expressing all sorts of rules for aggregating individual preferences. Because, well, aggregating individual preferences essentially amounts to, or it heavily uses probability theory. So I was wondering if we could, I was playing with this idea, if we could somehow merge these 2 worlds of probability theory with model logic, in the sense, for example, of weighting the accessibility relation with probabilities. So some worlds are more probable, more next to the actual world, and some worlds are more, let's say, far away, or have a difficult accessibility relation, in the sense that it is more improbable.
Yeah. I didn't work in this area, but what you say seems to me very, very interesting, very important, especially when we are thinking about some applications of model logic. For example, when we discuss, for example, the issue of feasibility. Is it feasible to do something? In this case, the idea is that some words are more probable than the others, or maybe they are not probable here, but they are probable when we move to an accessible one. And in this case, when we want to, when we would like to model feasibility, and that would be a very, very interesting and very important point. But unfortunately, I don't know very many things. I try to read a lot of things about feasibility, and there are also some attempts to formalize, including in model logic, but they are very simple, and I don't think they would help very much. I don't know.
Okay, thank you. Thank you. Well, if there are not other questions, or that there aren't other questions or comments or remarks, well, I again, from our collective, from our group, I would like to again thank you for your presentation, for your terrific presentation, and
It was my pleasure to be with you.
and hopefully you will honor us with another talk.
Of course,
Okay.
of course, of course. I'll be very happy, and I shall send to Paula the two papers. Okay.
Okay. Okay. Thank you
Okay.
very much again.
Bye.
Bye. Bye.
Thank you.